In this lecture, I am going to show you a couple of more functions so that you can consolidate your concepts about functions. Now, there are times when we are going to write down a function which needs not return any value, because the requirement is in such a way that we would be calling the function, and whatever task we are required to make it perform, that task will be done by the function, and the control will simply return back without returning with a value. Only the control will return. So I'm going to illustrate this with the help of an example. The statement goes like this: write a program that reads a number and passes it to a function that displays its reverse. The called function is not required to return a value. Okay, so this is the prototype of the function, and see it carefully. Now the name of the function in the prototype is being preceded with the keyword void. This is one of the 32 keywords of C language. Now whenever you see a function name being preceded with the keyword void, you should immediately come to understand that this function is not going to return a value. So then this is get reverse happens to be the name of the function, and within parentheses you have mentioned long. So that means at the time of calling this function, I am going to pass a long int value. I have declared it with the name num, and this is the prompt. We are getting the value from the user, as you are aware of this fact that format specifier for long int is either %ld or %li. Okay, here I am calling the function get reverse by passing this argument num. Now as you are familiar that at the time of calling this function, as I am passing this argument num, it will go and get stored into this num1. We are calling the get reverse function. It will find the get reverse function written over here. This is the body of your get reverse function. Okay, so this consists of all the statements of this get reverse function. So here we are calling from the main function. Value of num will go into num1. As you know, this num1 will be called formal parameter, or sometimes we call it dummy parameter. So num1 is right now containing the value of num. Okay, so now this is the control will enter into this body of this function get reverse, and I have declared a local variable called r. So this is the logic that we have already used in our programs when we were learning loops. This is the simple logic whereby we keep dividing the number with 10, getting the remainder and getting this remainder printed on the screen. So then again we divide the number with 10 and get the new quotient. Again this loop will go on until this value of num1 reaches 0. Okay, the logic has already been explained in the previous lectures whereby we were talking about loops. So this loop will print the reverse of the number, and because reverse of the number has been printed by the called function, there is no need to return any value. But one thing is for sure, the control will return back to the calling function. So when the return will go back to the calling function, after that, this is the termination of the function main. Your program will be terminated. If you just want to be sure whether the control has been returned back to the calling function or not, what you can do is you can simply write here any simple statement like suppose so when I will execute the program, after printing the reverse, if you see this message learning is fun, then it will be proven that the control returned back from the called function. So I am going to execute the program, enter the number will be passed to the function. Here in the called function itself we are printing this reverse, and afterwards the control returned back to the calling function. It will return back to the next statement where the function was called from, and printf is working. This is printing the message learning is fun. So this is an example of void functions. Void functions are the functions which do not return a value. So let me show you another sample program, and in this sample program what I am going to do is I am going to print the ASCII table. See, ASCII stands for American Standard Code for Information Interchange, and ASCII, all the ASCII codes, they are actually numerical representations of the characters used in a computer. So such as letters, digits, punctuation marks, special characters and control characters, etc. So they run from 0 to 255. So here I have written the function, and you will be this time over you will see a difference from the other programs. In the previous programs we were writing first the function main and we were writing the other functions below the function main, but in this example I have written the function above the function main. And see carefully, because in this case I am calling this function display, main will be called the calling function and display will be called the called function because it is being called. Always remember, if your called function body has been written above the calling function, then mentioning the prototype is optional. It is not mandatory. You can clearly see in the function main I am calling this function display, but I have not considered it necessary to give the prototype of this function. Why? Because the body of the called function happens to be above the body of the calling function. So here I am calling the display function. Of course, whatever is the location of the function main, one thing is for sure, at the time of the execution the control will first come into this function main. So the control will come to this function main, display function will be called, and in the display function I have declared a variable called a, which has been initialized with 0, because I have told you the ASCII values, they run from 0 through to 255. So I am making this simple loop while a is less than or equal to 255. Then I am going to print the ASCII value first in the numeric form and then in the character form, because each ASCII value represents a character. So in this printf I have used these scare brackets just for enclosing purpose. There is no special use of scare brackets over here, you can remove them. So in this case %d, in lieu of this %d, the first you have mentioned this variable a, its value will be printed in the form of a number, in the form of integer. Why? Because this corresponding format specifier %d is for the first variable a. Is equal to will be printed as it is, scare brackets will be printed as it is, and in lieu of this %c, the second variable is again a, that will be printed. And the beauty of using format specifiers in C is, when you would write %d and you are going to print the value of a numeric variable, it will print it as it is in the numeric form. But when you are going to print the same variable, but in the place of its format specifier you have specified %c, it's not going to print the value of the variable in the numeric form, but it will print its corresponding character, right? So corresponding character, which is the corresponding character of the ASCII value. So rest of the logic is quite simple. ++ a will increment the value of a, so it will go up. So then again it will print the value 1, and whatever character is for the ASCII value 1, then value of a will be incremented, and it will go on like this. This is the execution of the program. You can see it started from the ASCII value 0 and it printed nothing, because 0 is the ASCII value of null terminator that I have explained to you in the lecture of strings. So it is a non-printable character. This is for null terminator, and so on. It will go on printing all these sky values, right, till 255. This is the last one, 255.